Hello, am I audible? Can anyone please confirm?
Yes, ma'am.
Good evening everyone. I am Priya Tutwal. I am doing PhD at IIT Kharagpur under the supervision of Professor Sudeep Mishra. And today we will discuss the topics of week 5, and after that we will discuss some questions. So first of all we will discuss the challenges which are faced in IoT. So the first challenge is large scale cooperation. So basically in case of your IoT there are massive number of devices which want to interact with each other, so making the cooperation and coordination possible between these different kind of devices, it is difficult. The next one is global heterogeneity. So global heterogeneity means the devices which are present in your Internet of Things are heterogeneous. So the syntax which they are using, the semantics which they are using, or the vendor or the ones who produce those devices. So there are various parameters on which these devices differ from each other. So making the communication possible between these kind of heterogeneous devices, it become difficult. Next one is Next challenge is unknown IoT device configuration. Since we have millions of devices, and there might be some devices whose configurations are not known to the owners, so it becomes difficult for these devices to communicate with the other devices which are present in the network. The next challenge is semantic conflicts. So as different devices may use different kind of processing logics, so the semantic of the words which they are using may be different, so making the communication possible between such kind of devices is difficult. Now the solution to these challenges is interoperability. So interoperability is a characteristic of a product or system whose interfaces are completely understood to work with other products or systems, present or future, in either implementation or access without any restriction. So basically, interoperability means to make different devices to understand each other. So whatever with the syntax, whatever with the semantics. So considering all those things in to make by considering all those things, making the devices to communicate with each other. So this is interoperability. So with the help of interoperability, the communication between different devices become meaningful, and with the help of this, and by achieving interoperability, the devices can exchange data as well as services with each other. Now the need of interoperability. So to fulfill the IoT objectives, various IoT objectives, we need interoperability. So what are those objectives? First one is physical objects can interact with any other physical object and can share their information. So interoperability is required to make the communication possible between different physical objects. Second is any device can communicate with other device anytime from anywhere. So with the help of interoperability, the devices can communicate with each other irrespective of the place and irrespective of the time. So so with the help of interoperability, two devices which are using different languages, which are following different semantics, which are following different syntax, can interact with each other. The next one is machine to machine communication, device to device communication, device to machine communication. So in order to achieve this, interoperability is required. The next one is seamless device integration with IoT network. So for integrating your particular kind of device to the IoT network, interoperability is necessary. Now, as we were talking about heterogeneous devices, so what make these devices heterogeneous from each other? So maybe these devices use different wireless communication protocols such as your Zigbee, Bluetooth, GPRS, 6LoWPAN, Wi-Fi. So if two devices are using different communication protocol, it means these two devices are heterogeneous. So it might be the case that different wired communication protocols are used by the devices. For example, your Ethernet, higher layer LAN protocol such as your IEEE 802.1. So this thing also make your devices heterogeneous. Now there might be a case that different programming languages are used by your devices, or different kind of or different languages are used for making your websites. So these can also make the two devices heterogeneous. Now different hardware platforms such as Crossbow, NI, etc. Then heterogeneity. Then heterogeneity may be based on the operating system also. So maybe your one system is using one kind of operating system and other is using other kind of operating system, so that will also make your devices heterogeneous. So as an example, for sensor node, there are various kind of operating systems. So there might be a case that one of the sensor is using TinyOS and other one is using SOS. So these are different operating systems which are used in your sensor network. Then there might be a case that different databases are used by two different systems, then different data representation, different control model, and your syntactic and semantic interpretation. Now now the categorization of your interoperability. So interoperability is categorized into two categories. One is your user interoperability and second one is your device interoperability. User interoperability means the interoperability problem between a user and a device. However, your device interoperability means the interoperability problem between two devices. So from this figure, this is an example that, for example, there is one end user who want to access the services which is provided by your CCTV camera system. So consider a case that one CCTV camera system is present at Delhi and the other one is present as in Japan, right? So in Delhi, it might be the case that the language which is used can be either Hindi or English. American user is using English, and in Japan, Japanese is used. So there might be a case that so there might be a So, for accessing the services from a different location, there might be a case that the languages which are used be different. So, in order to make the use of different services which are provided by different systems, there is a need of interoperability between this end user and the service providers, that is your device A and device B. So using IoT, both A and B provide a real-time security service. A is placed at Delhi, India, while B is in Tokyo. B, A is using Hindi, B is using Japanese, and U is using English language. So if user U wants to use the real-time services of this CCTV camera, there is a need of interoperability between these three. That is your device A, device B, and your end user. Now the problems. So the user user does not know about the device A and B. Device A and B are different in terms of syntactic and semantic notions. Therefore, it is difficult to find CCTV device. So user U cannot understand the services which are provided by A and B until there is no interoperability. Similarly, A and B do not mutually understand each other. So if there is no interoperability between these three, then A and B are not going to understand each other, and at the same time user U is not going to find the services which are provided by your device A and B. Now the first kind of interoperability, that is user interoperability. So the following problems need to be solved. So first one is your device identification and categorization for discovery. Second one is your syntactic interoperability for device interaction, and third one is your semantic interoperability for device interaction. So the first one is device identification and categorization for discovery. So in order to do that, there are different solutions which generate unique addresses, which will further help in order to identify the devices. So here four different types of solutions are presented. First one is your EPC, that is electronic product code. Second one is your universal product code, that is UPC. Third is your URI, that is uniform resource identifier. And next one is your IP addresses. So with the help of these different solutions, you can identify your device. Now there are different device classification solution. So these are for device identification. Now you are going to categorize the devices in order to find the services. So first one is your UNS PSC. So UNSPSC is an open global multi-sector standard for efficient, accurate, flexible classification of product and services. The second one is E-class. So this standard is for classification and clear description of cross-industry products. Now syntactic interoperability for device interaction. So the interoperability between device and device user in terms of message formats. So how you are going to send your message, what are the different formats. So the interoperability which is achieved in terms of message format is called a syntactic interoperability. So the message format from a device to a user is understandable for the user computer. On the other hand, message format from the user to device is executable by the device. So what happened in case of your syntactic interoperability in case of your device interaction? So whatever is the message format of that is used by a device, that should be understandable to the user. On the other hand, whatever command your user is giving, your device should be able to execute that particular command. Now some popular approaches are service-oriented computing based architecture, web services, RESTful web services, open standard protocols such as IEEE 802.15.4, IEEE 802.15.1 and wireless HART can be used. Then closed protocols such as Z-Waves can be used. But these standards are these standards which I have listed here are incompatible with each other. Now the other solution which can be used in order to achieve interoperability is middleware technology. So you can use a middleware which can act as a middleman which will provide interoperability. So what will be the purpose of middleware? So what middleware will do, it will take the message of one device and convert the format of that particular device format of message to the message format which is understandable by the other device. So it dynamically maps the physical devices with different domains. Based on the mapping, the devices can be discovered and controlled remotely. Now cross-context syntactic interoperability. So it can be collaborative concept exchange using your XML syntax. Now the second kind of interoperability which is required for device interaction is your semantic interoperability. So semantic interoperability is the message. The last one is message format, the format which we use. However, here it is in give me 2 minutes. I guess there is some problem in recording. So we were discussing about semantic interoperability. So the interoperability between device and device users in terms of message meaning is your semantic interoperability. Now the device can understand the meaning of user instruction that is sent from the user to device. Semantic conflict refers to different processing logic applied to same IoT devices or applications. Similarly, the user can understand the meaning of device response sent from the device. Now the popular approaches which is used in order to achieve semantic interoperability is by using ontology. So there can be different kind of ontology. So one is device ontology, then second one is your physical domain ontology, and third one is your estimation ontology. Basically, ontology means knowledge of something. So in case of device ontology, different devices should have the knowledge of each other. So different kinds of words they are using. The devices which wants to interact with each other, they should know the knowledge. They should have the knowledge of the other device. Now, in case of physical domain ontology, the domain where your devices are used. So it might. So for example, in case of your blockchain transactions means the data which we want to store in that in blockchain, right? However, in normal terms, transactions means a financial exchange which take place. So the domain where exactly you are going to use, so in that particular domain what exactly the meaning of that particular term is. So that is your physical domain ontology, and third one is your estimation ontology. Now the next topic is collaborative conceptualization theory. So in case of your collaborative conceptualization theory, each object is defined based on collaborative concept which is called cosign. The representation of a collaborative sign is defined as follows. So cosign of an object is used in the form is used by using 4 different tuples. Which are mentioned as A, B, C, D, where A is the identifier, B is the natural language which is used, C is the context of A where A is used, and D is the definition of that particular object. So for example, if we are using a CCTV camera, right? So the sign for that particular CCTV camera is, so first one is the ID of that particular device. So ID of that CCTV, consider that it is 1234. The language which it understand is English. Now the context where it is used, so this is CCTV, and the definition is it is a camera. So it is a camera type with all these properties. So the solution approach is applicable for different domains and contexts. Now device interoperability. Till now we are discussing about user interoperability. Now in case of device interoperability, two devices should be able to understand each other. So the solution with the help of which we can achieve device interoperability is using your middleware, that is your universal middleware bridge, which solves seamless interoperability problem caused by heterogeneity of several kind of home network middlewares. UMB create a virtual maps among the physical devices of all middleware home networks such as Genie, Lawnworks, UNPNP, and creates a compatibility among these middleware home networks. UMB consists of two components. One is your UMB core and second one is your UMB adapter. UMB core is responsible for routing the universal metadata to the destination. However, UMB adapter is responsible for translating the messages into the global metadata message. So basically, consider this diagram. So here different kind of IoT devices are used, right? So these are using different communication protocols, they are using different kind of syntax, semantics, so all so basically these devices are heterogeneous to each other. Now this UMB adapter is responsible for converting the message format into a single type of message, that is your global metadata message, and further this UMB core is responsible for routing the message to the destination device. For example, consider that this power line wants to communicate with this IEEE 1394. Now the data format of this power line will be different from this one, right? So UMB adapter is responsible for converting the data format of this into the global metadata format. Now UMBC is responsible for routing the data to the destination, and again here UMB adapter will responsible for converting the global metadata into the local metadata of IEEE 1394. Now this is the definition of UMB adapter. So basically UMB adapter converts physical devices into virtually abstracted one as described by universal device template. UDT consists of global device ID, global function ID, global action ID, global event ID, and global parameters. UMB adapter translates the local middleware message into global metadata message. Now UMB core. So major role of UMB core is routing the universal metadata message to the destination or any other UMB adapter by middleware routing table. So UMB core is maintaining a routing table which is called middleware routing table, and with the help of the data which is stored in middleware routing table, it is transferring the data from one particular device to the destination device. So this diagram basically shows that how interoperability is achieved between different devices. So this I have already told you that basically your UMB adapter will convert the local message type into the global message type. Core is going to route the data to the particular, and at the end again you are going to use UMB adapter. So this is the same thing. So consider that this device wants to communicate with this device. So initially local control or monitoring message is sent, then this local UMB message conversion will take place into the global metadata. Then UMB core is going to send the data to the destination by using a query action request. Then UMB to local message conversion, then again the global metadata is converted into the local message, then again query action response is sent to UMB core, Then this again will send the response to the source device. Now the next topic which we are going to cover today is Arduino. So Arduino is an open source based electronic programmable board and software IDE. So can anyone please tell me that what is the difference between microcontroller and microprocessor? Anyone?
Microprocessor is only performing arithmetical operation,
Yeah.
while microcontroller is controlling also, means they are having the device like a resistor, so they are having different ports interrupt, so they are just controlling also.
Right. Basically, in case of your microprocessor, there is only control unit and ALU. Okay. So that is responsible for processing part only. However, in case of your microcontroller, the input output ports are there, your controlling part is also there. Okay. So that is the difference. Now Arduino accepts analog and digital signal as input and gives the desired output. No extra hardware is required in order to load a program into the controller board of Arduino. Now this table is showing the features of Arduino. So the operating voltage is 5 volt, the clock speed is 16 megahertz, the number of digital input output pins are 14, analog input pins are 6, PWM is 6, UART port is 1, and interface is USB by your at Mega 16 U2. Now the types of Arduino board. So basically different kinds of microcontrollers can be used in your Arduino board. So depending upon the microcontroller which is used, these are 4 different kinds of Arduino. So first one is your Arduino board based on Atmega 328 microcontroller. Second one is your Atmega 32U4 microcontroller. Next one is your Atmega 2560 microcontroller, and the next one is 8091 SAM 3x80 microcontroller. Now the board details. So basically this is the figure of your Arduino board. So here it is a power connector. This black color is a power connector. With the help of this you can provide power to your Arduino board. This is a USB connector. So in order to connect your Arduino board to your laptop or any other device, this is the USB connector. You can also provide power to your Arduino board through this USB connector also. And then these are the digital input output pins. Here this is the analog pin. These are 6 analog pins. After that there is one LED light, LED power indicator. Then one is your TXRX LED indicator, and then output power ground is also there. Now the IDE of your Arduino. So Arduino IDE is an open source software that is used to program the Arduino controller board based on variations of C and C++ programming languages. Arduino IDE is created. Now this is the figure. These two are the figures. So basically first of all you have to, in order to do the programming, firstly you have to select the Arduino which you are going to use. So for that you have to go to the tools. After that you have to go to the board, and then you can select the particular kind of Arduino which you are going to use. Now you also have to select the port through which you have made the connection. So it can be done. You have to go to the tools, then the port, and the port serial port which you are using. So in order to set up, power the board by connecting it to a PC by USB cable, or you can directly give the power by using the power adapter. After that you have to launch the Arduino IDE, then set the board type and the port of the board. So in order to set the board type, this is the figure, and in order to set the port, this is the figure. So you have to follow these steps. So for board you have to go to tools, then boards, and select your board which you are using. and for port, tools, port, and the port which you are using. Now the sketch. So the program which you are going to write in your Arduino IDE is called sketch. So in order to create a new sketch, you have to click on the file button, and after that you have to click on the new button. If you want to open the existing file, then you have to go to the file, then open, then you have to click the particular sketch view which you want to open. Now there are some existing examples of sketches which are present. So for that, if you want to open those, you have to click on file, then examples, and there will be a list of programs, a list of sketches which you can select. Now once you have written a code, for example, you have written this code, right? Now you have to verify that code. So in order to verify, this is the button, this tick mark. So it will check the code for the compilation error. So once it is done, you have to upload the final code to the controller board. Okay, and after that, so this arrow is the button for uploading the code. Now if you want to create a new sketch, then you have to click on new. So this is new. If you want to open, then this is the open button, and this is the save button. Now sketch structure. So your sketch is divided into two main parts. One is your setup and second one is your loop. So the function setup is the point where your code starts. So it is similar to the main function which is used in your C and C++. So from this point only, wherever your setup is there, your code will start. Now okay, the second main part is loop. So in the loop, you are going to write the task which you want to iterate. So for example, here it is written as serial.println hello Arduino. So this hello Arduino will be printed. Now these are the different types of data types. You can go through these. Now input output functions. So the Arduino pins can be configured to act as a input or output pins using the pin mode function. So for example, this is the syntax. So inside the pin mode, you have to write the pin which you are using and the mode, whether you want to use it in a read mode or a write mode. So these are the different functions. First one is your digital write. So it writes high or low value to your digital pin. Second one is your analog read. So it reads the analog input pin, that is your voltage applied across that particular pin. Then the other various kinds of functions are is digit, is alpha, is alphanumeric, is digit, is x digit, is lower, is upper, is space. You can use these different kind of function in your code. Now delay function is used in Arduino IDE in order to create a delay of a specific time. It accepts integer values, and the time which you are going to mention in delay function will be in milliseconds. So if you are going to write delay 5, it means it is going to create a delay of 5 milliseconds. Now this figure is showing one LED light. So here this LED is connected to the Arduino using the breadboard and connecting wire. So Arduino board is further connected to your PC, and we have to write the code in your Arduino IDE. So the whenever you will write a code and you will make the pin which is attached to your LED high, it will start blinking. So here this is the connection setup. So first of all, connect the positive terminal of LED to digital pin 12. So here it can be any pin number, and negative to the ground pin of the Arduino board. Then set the pin mode as output, which is connected to the LED pin 12 in this case. Use digital write function to set the output as high or low. Delay function is used to specify the delay between high-low transition of the output. So this is the sketch which is written. So in the setup, the pin mode is set as 12 and the mode is output. Now in the loop, digital write 12, because the pin which is used is 12. Then high will turn on the LED light, and after a delay of 1000 millisecond, that is 1 second, it will again do the LED to low. Low means it will turn off the LED. Here it is turn, I have written it is written as turn on, but it will be turn off. So after an interval of 1000 milliseconds, it will turn on your LED and turn off your LED. So this process will continue. So this is the settings, you can check. Now the operators and control statements which are used in Arduino IDE. So the arithmetic operators are similar to the operators which are used in your C or C++ language. So it is equal to, plus, minus, multiply, division, modulus. Comparison operators are given, boolean operators are there, then bitwise operator, compound operator. So these are similar to the operators which are used in your C language. Then the control statement. So similar to C, in C we have if, else, else if, right? So similar to that only, here we have if statement, if else statement, if else if else statement. So in case of if statement, you have to write if, then in bracket you have to put the condition, then curly braces, whatever task you want to perform, you can write inside your curly braces. So in case of if else statement, so if a statement is true, these set of statement will be performed, and if it is false, then these set of statement will be performed. So this is the syntax. And in case of your if else if else statement, so if statement if condition 1 is true, then this set of statement will be performed. If condition 2 is true, then this set of statement will be performed, and if both the conditions are false, then this set of statement will be performed. So this is similar to if else in case of your C language. Now switch case is also there in your Arduino. So you inside your switch you have to put the choice, and inside the curly braces you have to put the different options which are there. Then condition operator is also there. So basically here this is the syntax for condition operator. So here we have defined a variable. A variable is equal to condition. So if this condition is true, then statement 1 will be performed, and if it is false, then statement 2 will be performed. So this is the syntax for your conditional operator. Now for loop. So syntax is similar to your for loop in your C language. So for, then brackets. Inside the bracket you have to initialize the variable, then you have to put the condition and either increment or decrement, whatever you want to do, and after that curly braces and the statements which you want to perform inside the loop. Then while loop is there. So the syntax is same, while, then condition, and inside the curly braces you will write the statements which you want to perform. Then do while is also there. Do, then the set of statements which you want to perform, and then the while condition. RAM, okay, microcontroller and microprocessor. Now arrays. So arrays is a collection of elements having homogeneous data types that are stored in adjacent memory location. The conventional starting index is 0, so it is similar to C language only. Now the declaration of array. So in order to declare an array, you have to write the data type first, then the name of array and the size. So for example, int is the data type, then the name and the size. Alternate declaration can be a data type, name, and without giving size you can put the element which you are going to store in that particular array. However, in the second kind of declaration, you have mentioned the size as 5. So this is a maximum size. However, you have put only 3 variables, so the other 2 positions will be empty in this case. So whenever you are going to yeah, so next one is your multi-dimensional array declaration. So multi-dimensional means these are the types of single dimension, because only array are of single dimension. However, if you want to create matrix kind of thing, then you have to give the row, the column, and if you want to create 3D array, then you also have to give the height. So for declaring multi-dimensional array, you have to give the data type, then the name of the array, and the dimensions, whatever dimensions you want to give. Now strings. So array of characters with null as a termination is termed as a string. So whenever you are going to store character in an array and the last element will be null character, then it will be called as string. So declaration will be done with the help of arrays only. So for example, here you have to mention the data type. So as you are going to store characters in string, so char will be the data type, then the name, and then the size. So basically you are going to store ABCD. So okay, it is written it is incorrectly written over here. So string at 0th position it will be 1, here it should be 1. So at first position B will be stored, at second position C will be stored, and at the last position D will be stored, and then at the last null character will be stored. Then the functions of string object. So you can use different functions. For example, str dot to uppercase. So it will basically convert all the characters of that particular string to uppercase. Then str dot replace string 1 comma string 2. So this function is going to replace string 1 with string 2. Str dot length is going to give the length of the string without considering the null character. For example, if you want to calculate the length of ABCD, then it will give 4. It will not consider the null character. Now the random numbers. So in order to generate random numbers, different kind of functions can be used. So first one is your random seed, and inside you have to put the seed value. So it reset the pseudo random number generator with seed value v. Second one is your random maxi. So this function gives the random number within the range of 0 comma maxi. So for example, if you are going to put random 10, so it will generate the random number between 0 to 10. Then the third is random mini comma maxi. So it is going to give the random numbers within the range of mini comma maxi. Now the integration of sensors with Arduino. So you can integrate different kinds of sensors with your Arduino. You can integrate different kinds of actuators with your Arduino. So here it is an example of integrating your DHT sensor with Arduino. Yeah, so DHT is digital humidity and temperature sensor. So it has 4 pins, pin 1, 2, 3, 4. So pin 1 is your power supply pin. So it takes either 3.3 volt to 5 or 5 volt. Pin 2 is your data pin, pin 3 is null pin, and pin 4 is ground pin. So Arduino support a special library for your DHT11 and DHT22 sensors. So if you want to use your if you want to integrate your DHT sensor with Arduino, you can use that library. Basically that library provide various functions. For example, dht.read humidity. So this function is used to read the humidity value. dht.read temperature. So this function is going to read the temperature value. So basically, in order to add that library to your sketch, you have to go to the sketch. After that, you have to click on the include library, Then on manage library, then this interface will come up. You have to write the DHT, and after that you have to click here. It will be an install button. You have to click over there, and that particular library will be installed. Now similarly, as you have integrated a sensor with your Arduino, you can integrate actuators also. So for example, if you want to integrate actuator, that is your servo motor, with your Arduino, firstly you have to make the connections. After that, in order to do some functionalities, you have to add the library. The servo library is already present, so for that also you have to follow these steps only: sketch, include library, then here manage library, you have to write servo, or sometime here also you will get an option to add servo. Right, so servo motor is a high precision motor which provide rotary motions of 0 to 180 degree. Three wires are there in servo motor. So black or the darkest one is used for ground, red one is for power supply, and yellow is for signal. So Arduino provides different library for servo to operate the servo motor, and in order to use that particular, you have to create an instance of servo to use it in the sketch. So for example, servo, my servo, you have to create the instance like this only. Now questions, but before starting question, let's take a break of 5 minutes. Monica, you have raised hand. Do you have any question?
Yes, thank you for your valuable means concept. Ma'am, I'm having one doubt that you described about the uploading the program in Arduino through Arduino IDE software, right, ma'am?
Right, right.
Yeah. So, ma'am, while uploading, is there is any criteria? Because while uploading, there is some in section of the tools, compiling option is there, and after that, the selecting option is there. So for serial port, it is automatically coming like COM 5632, whatever it is having.
Right, right.
And for processor and other section, which particular option we have to select for Arduino Uno only?
Yeah. I'm not getting what you have said in the last.
Ma'am, which setting we have to keep while uploading the program? Like one the Arduino we have to select. So we are choosing Arduino Uno, and in below that one another option is there. At Mega option is there. At
Yeah.
Mega
See,
ISP option is there.
whatever Arduino you are using, you have to firstly select that Arduino. After that,
Yeah,
you can upload. For example, if you are using Arduino Uno,
yeah.
then you have to select Arduino Uno. If you are
I,
using another kind of Arduino board, then you have to select that particular Arduino.
okay, and that is regarding the Arduino board. In board selection, we are selecting the Arduino,
Yeah.
and below that another option is there to select the type or processor or the port which we are using. So in
That
that,
is
which
the port.
particular?
So basically, if you are making the serial connection between your laptop and Arduino board, then you have to select that particular port number. So basically, that will be the port through which you are making the connection to your Arduino.
Okay, and there is option of at Mega as ISP, and various options are there. So I'm not exactly getting what is that actually.
Which option? Can you please repeat? Can you please write in the chat box? I'm
Okay,
not
ma'am.
seeing.
Okay, fine, ma'am. I'm just typing it. Thank you, ma'am.
Okay. already uploaded in the same drive. Wait, I'll give you the link. So this is the link of the drive where I have uploaded all the PDF files till week 5. My screen is visible, right? Hello, Monica. Processor selection
Yes,
in
ma'am.
IDE software. Okay, I'm opening the IDE. Okay, tools. Then where exactly you are saying?
And
These
ma'am,
are
I'm
different boards, right? So whatever board you are going to use, for example, if I am using Arduino Uno, then I have to select that particular Arduino. Then these are the different ports which you are using. So you are saying about,
yes, ma'am. Ma'am, below that, ma'am, can you just go in the tool section?
yeah, tools, right?
Yeah, and the board is chosen, a port is chosen, and below that programmer option, right? The programmer option, yes, this one.
Okay. So okay, this I'll check. I also don't know about
Okay,
that.
ma'am, you can
I'll check.
check it, and afterwards you can reply me. No issue, ma'am.
Right, right.
Thank you so much, ma'am.
Okay. Okay, let's start questions now. Wait,
Excuse me, ma'am.
yeah.
Ma'am, actually, I had a doubt.
Yes.
Ma'am, IoT, as we are using IoT, it means that we are sharing the data between different nodes or between different microcontrollers. So,
Yeah, it can be between different microcontrollers, it can be between different devices, it can be anything, right?
yes. So suppose if I want to monitor my garden when I am in US and
Okay.
my garden is in India, but it is not possible using Arduino. But while ESP32 supports the Wi-Fi module, so it is
Right.
possible. And
Yeah.
as before we have discussed many of the protocols, so is it possible that using via different protocols that Arduino Uno can also support the specification to just give me the data while I am in US?
Yeah, you just have to add, see, this Wi-Fi module is not there, right? So you just have to attach extra Wi-Fi module and you can do that also. So by
Okay.
just using protocols, you cannot achieve this, right? You have to use something with the help of which the communication can take place. So it will not be possible with Bluetooth or something like that. You have to use Wi-Fi, right? So for Arduino, you have to attach external Wi-Fi module, and by doing that, you can do.
Okay, ma'am. And
Okay. Your voice is not coming. Are you asking something else also?
Yes, ma'am.
Repeat, please.
Ma'am, can you please explain collaborative conceptualization theory?
Collaborative conceptualization theory basically is used for providing the interoperability, right? So, in order to identify a device, in what context that particular device is used, you are going to use this collaborative conceptualization theory. So, what this theory is saying that for a particular kind of device, you are going to use four different tuples in order to define that particular device. So, one that will be A, B, C, D. Right? I'll show that particular slide first. Yeah. So, in order to identify a particular device, so in what context that device we are going to use, you are going to use collaborative conceptualization theory. So basically this theory suggests that in order to identify a device, you are going to use four tuples. So A is used as an identifier. So whatever be the ID of that particular device, you are going to store in A. Then B will be the language which is identified by that particular device. For example, in this case it is English. Then C is the context where exactly that particular device is used, in what context that device is used, and D is the definition. So with the help of this conceptualization theory, you are going to identify a device, that where exactly this device is suitable, what kind of language it is using. So with the help of this, achieving interoperability will be easy. Is it clear?
Yes, ma'am. Thank you so much. Yes, ma'am.
Okay. Any recording sessions available? Yeah, I'll upload these sessions to YouTube. So wait, I'll give you the link also. This is the link for the previous video, the lecture, previous week's lecture. And today, after this session, I'll upload this video on YouTube. You can go through that, and if required, I'll give you the link in the next session of this particular week. Okay. Now I'm starting with the questions. I 2.4 the other based devices. Options are yes, no, not applicable. Anyone? What?
Would you be kind enough
Yeah.
to type in the chat window
Okay.
on the books that you have just referred to,
Yeah,
please?
sure.
Thank you.
I'm in introduction to thing. Yeah, so now we will discuss the questions of week 5. So first question is, does 6LoWPAN allow interoperability between IEEE 802.15.4 based wireless devices as well as other IP based devices? Options are yes, no, not applicable. I'm repeating the question. Does 6LoWPAN allow interoperability between IEEE 802.15.4 based wireless devices as well as other IP based devices? Options are yes, no, not applicable. So the correct option for this question is yes. 6LoWPAN allows interoperability between IEEE 802.15.4 based wireless devices as well as other IP based devices. 6LoWPAN simply uses a bridge to enable the communication between these devices. So basically this bridge is responsible for making the communication between different devices possible. So this bridges the gap between the standards which the different devices are using. So this bridge is going to remove that gap and provide a standardized way with the help of which these devices can communicate with each other. Next question is, servo motor works on the principle of, options are electromagnetism, PWM, that is pulse width modulation, magnetism, none of these. I am repeating the question. Question is, servo motor works on the principle of electromagnetism, pulse width magnetism, modulation, next one is magnetism, then none of these. So the correct option for this is PWM, that is your pulse width modulation. So servo motor works on the principle of pulse width modulation, means its angle of rotation is controlled by the duration of applied pulse to its control pin. So basically this pulse width modulation is commonly used control technique that generates analog signals from digital devices such as your microcontroller. The signal thus produced will have a train of pulses, and these pulses will be in the form of square waves. Thus at a given time the wave will either be low or high, and by using those waves the rotation of this servo motor can be controlled. Now how the pulse width modulation signal is generated. So basically a pulse width modulating signal is generated using a comparator. So modulating signal forms one part of the input to the comparator, while the non-sinusoidal wave or sawtooth wave forms the other part of the input. The comparator compares two signals and generates PWM signal as its output waveform. And if the sawtooth signal is more than the modulating signal, then the output signal is in a high state. The value of the magnitude determines the comparator output, which defines the width of the pulse generated by the output. Now next question is, which of the following is not a commonly available Arduino board in the market? Options are Arduino Uno, Arduino Mega, Arduino Nano, Arduino Duo. So the correct option for this is Arduino Duo. So basically this Arduino Uno, Arduino Mega, Arduino Nano and Arduino Duo are present in the market. After this there are various compatible systems present which are compatible with your board. So although the hardware and software designs are freely available under copyleft licenses for Arduino, the developer have requested that the name Arduino be exclusive to the official product and not be used derivative works without any permission. So the name Arduino, the processor which is used is Atmega 328P. Then Sedeno Cortex, the processor which is used is SAM D21 Cortex. Then Sedeno Lotus, processor is Atmega 328P. Then Seduno Lotus Cortex MO, the processor is SAM G21 Cortex MO, and likewise there are various other boards available which are using different processors. After that, the next question is different processing logics applied to same IoT network devices or application is classified as. Options are semantic conflict, configuration conflict, processing conflict, heterogeneity conflict. So different processing logics. So the correct option for this is semantic conflict, because in case of your semantic conflict, if the message is not understandable, then semantic conflict occur. Here it is written that different processing logics applied to same IoT network devices, then the problem which will occur is your semantic conflict. After that, it is also important to note that providing semantic description alone does not provide semantic interoperability and will not solve all the issues regarding discovery, management of data, and supporting autonomous interaction. The semantic description still needs to be shared, processed, and interpreted by various methods and services across different domains. Um, so defining an ontology and using semantic configuration for data will make it interoperable for users and stakeholders that share and use same ontology. In the IoT domain, different stakeholders need to have a common agreement on ontology definitions. Most of the current ontology and semantic description framework in the IoT domain are defined in the context of different projects and applications, or they are currently at an early stage. So to achieve the global scale semantic interoperability, common semantic annotation framework, ontology definition, and adaptations are the key issues. So the conflict which is related to your processing logics is called your semantic interoperability, semantic conflict. Next question is, which of the following is true for collaborative conceptualization theory? Options are: it overcomes the limitation of ontology, it enables cross-context semantic interoperability for any object. Third is, it both overcome the limitation of ontology and enable cross-context semantic interoperability for any object. Next one is, it represents the things as symbol for semiotics. So which of the following is true for collaborative conceptualization theory? So the correct option for okay, first of all I'll tell you that what exactly is collaborative conceptualization theory, and after that I'll tell you that which is the correct option. So in case of your collaborative conceptualization theory, each object is defined based on the collaborative concept, and that concept is called cosign. The representation of collaborative sign is defined as follows. So a cosine of an object is defined by using four attributes A, B, C, D. So basically A refers to a sign internal identifier, B is the natural language, C is the context of the A, and D is the definition of the object. So, for example, in the case of your CCTV camera, which we have discussed earlier, the cosine will be first is identifier. So, identifier is taken as 1, 2, 3, 4 here. The natural language is English. The context of A is it is a CCTV, and camera, and then the definition. So, camera type is bullet. Then communication uses network IP, and the horizontal resolution is given as 204.48 TVL. So this solution approach is applicable for different domains context. After that, yeah, so this collaborative conceptualization theory is used to overcome the limitation of ontology, and uh, it also enables semantic cross context semantic interoperability for any object. After that, the next question is, which of the following is true for the following command? Serial begin 9600. Options are Arduino exchange messages with serial monitor at a data rate of 9600 bytes per second. 9600 represent binary ones and or zeros per second. Both Arduino exchange messages with serial monitor at data rate of 9600 bytes per second and 9600 represent binary ones or zeros per second. Last one is Arduino exchange messages with serial monitor for 9600 simulation time. So which of the following is true for this? So the correct option for this is B, that is your 9600 represent binary ones or zeros per second. Basically, this serial begins sets the baud rate for serial data communication. The baud rate signifies the data in bits per second, not bytes per second. So first option is incorrect. Bits per second means either 0 or 1. So 9600 represent here binary 0, 9600 bits per second. The default baud rate of Arduino is 9600 bits per second. We can specify other baud rates also, for example your 4800, 14400, anything. Okay. So this serial begin is declared in two format. Basically you can write begin, then in the begin you can write the speed, and also the other way is serial begin, along with speed you are going to specify the configuration. Okay, so configuration means speed first of all mean it signifies the baud rate or bits per second. So in this example only speed is mentioned. However, the configuration means it sets the stop parity and the data bits along with. For example, here it means 9600 bits per second. So the correct option for this question is, that's why 9600 represent binary zeros or ones per second. Next question is, which of the following standards can be utilized as device catalogs? Options are E-class, UNSPSC, both UNSPSC and E-class. Next one is none of these. I am repeating the question. Which of the following standard can be utilized as device catalogs? Options are E-class, UNSPSC, both UNSPSC and E-class, none of these. So the correct option for this is both UNSPSC and E-class. So basically what happened is, with the continuous improvement of Internet of Things technology, various IoT platforms are under development. However, each IoT platform is developed based on its own device identification system. That is, it is challenging to identify each sensor device between heterogeneous IoT platform owing to resource request format, for example your device identifier, varying between the different platforms. Moreover, despite the considerable research focusing on resource interoperability between heterogeneous platforms, little attention is given to sensor device identification system in diverse IoT platforms. So, in order to overcome these issues, various methods, the researchers have provided various methods in order to provide identification to your IoT devices. So these are the two of the methods or standards which are provided by the researcher. So one is your UNSPSC and other one is your E-class. So correct option for this is C. Next question is, which of the following enables interoperability? Options are cloud computing system, sensor nodes, middleware, all of these. Yeah. So which of the following enables interoperability? Options are cloud computing system, sensor nodes, middleware, all of these. So the correct option for this is middleware. Basically what happened is, there are various devices present in the IoT network, and all these devices are following a different standard, different protocols, right? Maybe the operating system on which these devices are running, maybe these are the different. So it becomes difficult for these devices to interact with each other. So in order to make communication possible between two different devices who are following different standards or different communication protocol, middleware can be used for making their communication possible. For example, consider two devices which are using two different communication media, for namely Bluetooth or 6LoWPAN, right? Now we need these devices to interact with each other, so we need to put some middleware in between those two devices, which will interface your both the devices, that is your Bluetooth interface as well as your 6LoWPAN interface. So that particular middleware is going to take the data from the one device and convert that data into a particular standard, and further whenever it will send the data to your the other device which is following 6LoWPAN, it will convert the particular data to the respective standard. So the next question is, which of the following is true for the sketch command given below? Delay 1000. So options are, it provides a delay of 1000 second, it provides a delay of 1 second, it provides a delay of 1000 simulation time, it provides a delay of 1 simulation time. So delay 1000. So basically delay function in Arduino Uno takes integer value, and the integer value is in millisecond. So basically if you are putting delay 1000, it means 1000 milliseconds. So 1000 milliseconds means 1 second. So the correct option for this question is it provides a delay of 1 second. And the way this delay function work is very simple. It accepts single integer, and this integer represents the time basically, and the time is in millisecond only. So the program should wait until moving on to the next line of code when it encounter this function. Whenever your program will encounter this function, it will wait for that particular amount of time, and after that it will go to the next line of the code. Next question is, in a sketch, string can be declared using array, string object, both array and string object, none of these. So in case of your in a sketch, you can declare your string with the help of array as well as with the help of string object in Arduino. So the correct option for this is both array and string object. So basically when you are going to declare your string with the help of array, so what will you do is, first of all you have to mention the data type, and further you have to give the name. For example, ARR is the array name, and after that you have to specify the size. For example, you want to store ABCD, right? So the size is 4. However, in case of string, there is one null character also at the end. So you are going to create an array of 5, and in that particular array you are going to store the variables, that is your ABCD. So at 0th position you can store A, at 1st position you can store B, at 2nd position you can store C, and at the 3rd position you can store D, and at the last you can store null pointer. However, the string objects also allows you to manipulate the text of the text in a variety of useful ways. So with the help of this, you can append characters to string, combine string through concatenation. You can get the length of the string also. So all these functions can be done with the help of your string object, and also you can declare string with the help of string object also. Now the next question is, in syntactic interoperability between devices and device user, the message format from the user to the device is blanked by the device. Options are understandable, executable, both understandable and executable, none of the above. So in case of your whenever there is a syntactic interoperability and a user wants to interact with a particular device, then that user should be able to understand the messages which are sent by the device to the user, and the device should be able to execute the commands which are given by the user to your device. So the correct option for this is executable, because the message format from the user to the device should be executable by the device. So the correct option is executable. So applications can take advantage of parsers and APIs in order to provide the syntactical manipulation facilities. So if a language is standardized, it is used actively and required parsers and APIs are implemented. Okay, so in the case of your syntactic interoperability, the syntax of the message or the format of the message should be understandable. Next question is, in a sketch, which of the following function initialize input output variable and pin modes? Options are initialize, loop, setup, init. Question is, which of the following function initializes input output variables and pin modes? So the correct option for this question is setup. So basically the Arduino programs calls the setup function as the first thing when the Arduino unit powers up. So any code that you place in a setup function in your sketch runs the first, and it only runs one time. So it is basically similar to your main function. The setup function is a great place to initialize input and output pins, so they are ready to be used. So the correct option for this is setup function. Next question is, which does pin 3 from left to right as shown in the figure in digital humidity and temperature sensor signify? Options are power supply, data, ground, none of these. Which does pin 3 from left to right as shown in figure below in digital humidity and temperature sensor signify? Options are power supply, data, ground, none of these. So basically your DHT sensor, that is your digital humidity and temperature sensor, is used to sense the humidity as well as the temperature values. It consists of 4 pins. Pin 1 to pin 4. First pin, that is your pin 1, is responsible for getting power, so it is the power supply pin. Pin 2 is data pin, pin 3 is null, and pin 4 is ground. So basically pin 3 is null, right? So in the options there is no null option, so the correct option for this question is none of these. Next question is, which of the following best describes the command given below? Command is servo demo write 180. So options are creates an instance of the servo, pin writes 180 to the servo, servo moves 180 degrees, and last one is all of these. So which of the following describes this? The correct option for this is it moves the servo by 180 degrees. So basically your servo motors have 3 wires, that is your power, ground and signal. The power wire is typically red and should be connected to the 5-volt pin of the Arduino board. The ground wire is typically the black or the brown one, the darkest wire, and it should be connected to the ground pin of your Arduino board. The signal pin is typically the yellow, orange or the white one, and it should be connected to the digital pin of the Arduino board. So whenever your servo draws the considerable amount of power, it will start working, and this servo demo write is responsible for moving the motor by 180, as it is mentioned that 180 in the servo, right? So it will move servo by 180 degrees. Other methods that are associated with servo library is attach, write, write microseconds, read, attached, detach. Further, the library which is used is servo.h. So whenever you are going to use servo motor, you can use the library servo.h. So this library allows an Arduino board to control the servo motors. Servo have integrated gears and shafts that can be precisely controlled. Standard servos allows the shaft to be positioned at various angles, that is 0 to 180 degrees, and continuous rotation servos allows the rotation of the shaft to be set to various speeds. The servo library support up to 12 motors on most of the Arduino boards and 48 on the Arduino Mega. On the boards other than Mega, the use of library disable analog write functionality on pins 9 and 10, whether or not there is servo on those pins. On Mega, up to 12 servos can be used without interfering with PWM functionality. Use of 12 to 23 motor will disable PWM on pin 11 and 12. Next question is, which of the following is an interoperable system commonly used for automation? Options are Lawnworks, Dropbox, ThinkSpeed, all of these. Which of the following is an interoperable system which is commonly used for automation? So the correct option for this is Lawnworks. So Lawnworks is an open standard for networking platform specifically created to address the needs of control application. The platform is built on a protocol created by Echelon Corporation for networking devices over media such as your twisted pair, power lines, fiber optics and RF radio frequencies. It is used for the automation of various functions within buildings such as your lighting, building automations and all those things. After that, there are various applications of your Lawnworks. For example, in your semiconductor manufacturing, lighting control system, energy management systems, heating, ventilation, air conditioning systems, security system, home automations, consumer appliance control, public street lighting, monitoring and control, petrol station control, rail electronic controlled pneumatic braking, all these are using Lawnworks. Next question is, which of the following UAB topology is self-configuring? Options are mesh, star, both mesh and star, grid. Basically, UAV have two topologies, that is your mesh and star topology. In case of your star topology, there is one flying object to which all the other objects are interconnected, and that flying object are connected to your ground station. The other possibility of star is all the flying objects are interconnected to one ground station only. Okay, so in case of star, if the middle or the central node get defected, then the communication between all the other nodes cannot take place, right? So in that case, it is not self-configuring. However, on the other hand, in case of your mesh topology, each and every node is interconnected with other nodes, right? So if by chance one particular link is corrupted, then the nodes can interconnect with each other or can communicate with each other through other nodes. Fine. So in the mesh topology is self-configuring. So the failure of one particular link is not going to affect the communication of the network. So the correct option for this is mesh topology. Next question is, UMB consists of, options are UMB A and UMB C, UMB A and UMB B, UMB B and UMB C, UMB A and UMB E. So the correct option for this is UMB A and UMB C. So basically your UMB consists of your UMB core and UMB adapter. So whenever two devices which are following different protocols and standards wants to communicate with each other, then we are going to place UMB over your that devices, the protocols which are using by those devices. So UMB adapter sits over the protocols which are used by those devices and is going to create a virtual device for each of the device. Okay, so whenever these virtual devices are formed, then a global metadata is created. So that global metadata is understood by the network. So further this global metadata is used by UMB core in order to route, and whenever the other adapter receives that UMB that global metadata, it is going to further convert that global metadata into the local message again. The next question is, UMB creates virtual maps among the blank of the middleware blank of all middleware home networks. Options are virtual device, physical device, heterogeneous device, services. The correct option for this is physical devices. Basically, UMB creates virtual maps among the physical devices of all the home networks such as Heavy, Genie, Loanworks and UPnP. So basically, the integration of computing power and communication into next generation of everyday device is one of the major factor that is deriving the emergence of home networks, which interconnect various appliances, enabling remote access and control of those appliances and any available service such as home entertainment, home office and home automation. Nowadays, the increasing diversity of home devices implies that various kinds of home network middleware will be working in home, because these devices typically have severely restricted computation resources. Middleware technologies most appropriate for these devices are continuously turned up. It is highly improbable that there will be a single dominant home network middleware platform that would be good enough for various appliances and purposes in near future. It is a key element for achieving digital home to provide interoperability among the heterogeneous home network middleware, which have quite different command and data delivery mechanism. Because currently most available home network middleware such as your Heavy, Genie, Loanworks, UPnP have no compatibility with each other. Home devices based on these heterogeneous middleware cannot communicate with one another, even though they are physically connected. Therefore, there is a need of a software. So, for example, your universal middleware bridge that can be used to solve the interoperability problem caused by heterogeneity of several kind of home network middlewares. Next question is, which of the following is the functionality of UMB adapter? Options are, it translates the local middleware message to global metadata message, it translates the global middleware message to global metadata message, it translates the local middleware message into local metadata message, it translates the global middleware message to local metadata message. correct option for this question is UMB convert physical devices into virtually abstracted one, which translate the local middleware message into global metadata message. So the correct option for this question is A, that is translate local middleware message into your global metadata message. Question number 20th. Which of the following is true? Option A is relay is an actuator that uses electromagnetic effect to act as a switch. Relay can open and close circuit when electricity is passed through it. Relay can be used to control power supply to any other connected device. Next option is all of these. So which of the following is true? Basically, your IoT power relay is a controllable power relay equipped with 4 outputs that help you to create an Internet of Things uh, project with safe and reliable power control. With IoT power relay, you can easily control the power going to the device within Arduino or Raspberry Pi. Okay, so it is basically an electromagnetic component. Electronic component that uses electromagnet to act as a mechanical switch. So first statement is correct. The main purpose of relay is to switch on and off high powered circuit from a low powered circuit. A relay switch can be seen in many different shapes and sizes, color, electrical rating and capabilities. The component rating is one of the most important aspects that should be considered while you are purchasing a relay for your project. So if we use a relay that cannot support the power that it will be used in, that will be a problem. So the correct option for this is all of this, because relay is an actuator that uses electromagnetic effect to act as a switch. It can open or close the circuit when electricity is passed through it, and it can be used to control the power supply of any other connected devices. Next question is, what is a sketch? Options are program coded in IoT devices, program coded in Arduino IDE, services of Arduino Uno, services of IoT devices. So which of the following is sketch? So the correct option for this is program that is coded in your Arduino IDE. So it's a unit of code that is uploaded to and run on the Arduino board. So the correct option for this is B, that is your program coded in Arduino IDE. So for running a sketch, what you'll need is a computer, Arduino IDE installed on that computer, an Arduino board, and a compatible data USB cable which is interconnecting your computer with your Arduino board. Next question is, what is the function setup? Point where code terminates, point where code starts, it iterates the task in the program, none of these. So what is function setup? So the correct option for this is the point where code starts. So the setup function is called when your sketch starts. The code use it to initialize the variables, pin modes, start using libraries. The setup function will only run once after each power up and reset of the Arduino board. Next question is, which of the following is true for the given command? Random 10. Options are, gives random number within the range 0 to 10, give a random number within the range 1 to 10, give random number within the range 0 to 9, reset the pseudo random number generator with seed value 10. So the correct option for this question is A. So whenever you are going to put some value inside your random function, then it is going to generate the random number between 0 within the range 0 to that particular value. For example, random max I means your code is going to generate the random number between 0 to that particular max I value, and if it is like random min I and max I, then it is going to create the random number between your within the range min I to your max I. Next question is, which kind of conflict occur when different processing logics are applied to same IoT network devices or applications? Options are semantic conflict, syntactic conflict, system conflict, device conflict. So the correct option for this question is semantic conflict. So semantic conflict occurs when different processing logics are applied to same IoT network devices or application. Semantic conflict basically means the message logic is not understandable. The meaning of the message is not understandable by the different devices. Next question is, which of the following is true for sketch command given below? Delay 3000. Options are, it provides a delay of 3000 second, it provides a delay of 3 second, it provides a delay of 3000 nanosecond, it provides a delay of 3000 simulation time. Basically, this delay function takes the value integer values which are mentioned in millisecond. So if you are passing 3000, it means 3000 milliseconds. So delay function is going to create a delay and it will execute the next statement of your program after that particular delay. So 3000 means 3000 milliseconds, which means 3 seconds. So it provides a delay of 3 seconds. So B is the correct option for question number 25. Next question is, which of the following solutions are not responsible for generating unique addresses? Options are election product code, unique product code, uniform resource identifier, IP addresses. I am repeating the question, which of the following solutions are not responsible for generating unique addresses? Options are election product code, unique product code, uniform resource identifier, IP addresses. So I am going to the slides where we have discussed this topic. Yeah. So these are the different solution for generating the unique addresses. First one is your electronic product codes. Second one is your UPC, that is your universal product code. Third is your uniform resource identifier, and fourth one is your IP addresses. So there we have options. One is your election product code, second is your unique product code, third is your IP addresses, and fourth one is your URI, that is uniform resource identifier. So both A and B in this question are incorrect because EPC stand for electronic product code and UPC stand for universal product code. So both A and B are incorrect for this question. Next is, how many digital input output pins are there in Arduino Uno? Options are 14, 54, 11, 16. So in case of your Arduino Uno, how many input output pins are there? Options are 14, 54, 11, 16. So the correct option for this question is 14. So in case of the Arduino Uno, we have 14 digital input output pins and 6 analog input pins. Next question is, blank dynamically maps physical devices with different domains. Options are collaborative concept, middleware technology, end devices, cloud. Blank dynamically maps physical devices with different domains. Options are collaborative concept, middleware technology, end devices, and last one is your cloud. So the correct option for this question is middleware technology. So middleware technology dynamically maps physical devices with different domains. Next question is, which of the following ontology utilize previous data to estimate what is going to happen? Options are device ontology, physical domain ontology, estimation ontology, virtual domain ontology. The correct option for this question is estimation ontology. So C is the correct option. So estimation ontology utilize previous data to estimate what is going to happen next. Next question is, which component of UMB converts physical devices into virtually abstracted one as described by UDT, that is Universal Device Template? Options are UMB A, UMB C, UDT mapping, UMB B. So which component of UMB converts physical devices into virtually abstracted one? So UMB consists of two components. One is your UMB A, that is your UMB abstract, and second one is your UMB adapter, and second one is your UMB C, that is your UMB core. So UMB adapter is responsible for converting the physical devices to the virtually abstracted one. However, your UMB core is responsible for routing. So the correct option for this question is A, that is your UMB A. next question is the interoperability between devices and device users in terms of message formats is called blank. Options are systematic, semantic, syntactic, device. So in question it is given that in terms of message format. So in terms of message format, the interoperability that is there is syntactic, and if it is message meaning, then it is semantic. So the correct option for this is syntactic interoperability, that is C. So these were the questions of week 5. And yeah, so you can for answering these question and to get more idea about these topics, you can follow the books also. The name of the books are first book is Introduction to Internet of Things by Sudeep Mishra, and second one is Introduction to Industrial Internet of Things and Industry 4.0. So if you want to get more insights about the topics which I have discussed today and the questions which I have discussed, you can follow these two books apart from the lectures which are available on the NPTEL. So you can follow these two books also. I am going to upload these slides over the Google Drive link, and the link will be provided to you in the description of the YouTube video, and I'll upload the video also. So if you want to watch this again, then you can check the YouTube video. Okay, someone is asking, ma'am, I have one doubt, what procedure I have to follow for getting top rank in this exam? Okay, so follow the videos which are there, after that solve the assignments, then also read the books, that is Introduction to Internet of Things and that Introduction to Industry 4.0 and IIoT. Okay, so if you will do all those things, then you will get top rank in this exam.
Would you be kind enough to type in those books for us, please?
What?
Would you be kind enough
Yeah.
to type in the chat window
Okay.
on the books that you have just referred to,
Yeah,
please?
sure.
Thank you.
I'm ready. First one is introduction to thing. Second thing is